Let's talk in some more detail about the friction force. Now, what is friction? Most everything has friction. There's some objects that have a low friction, some that have a high friction. You'll notice that rough objects have more friction than smooth objects, but at a microscopic level, everything has a rough surface. So friction is the force caused by two rough surfaces sliding across each other. And even if something is very smooth looking, like the top of a table, very smooth looking, the surface of a mirror, it's still going to be rough at a microscopic level. And friction always acts opposite the direction of motion. So if two objects are sliding across each other, friction is always opposite the direction of motion. Now, there are two different types of friction. The first type we call static friction. We denote that as Fs. This is the force of friction between two stationary surfaces. It's a static situation, so you have two stationary surfaces. Now, if you have two surfaces that are sliding across each other, we call that kinetic friction. Denote that with an Fk. Anytime you have two surfaces that are sliding, you're going to have kinetic friction. Now, think about this one. You have a wheel on a car, and the car is driving. The wheel is rolling. Is that going to be static friction or kinetic friction between the wheel and the ground? It's actually, a lot of people think that's going to be kinetic friction because the car is moving, but if you think about the actual point of contact between the wheel and the ground, there's not sliding happening. At least there shouldn't be. If there was, you'd be skidding around a corner or something, and that wouldn't be good. But the point of contact between the two surfaces is not moving. So it's actually static friction between a wheel and the ground. Static friction is always greater than kinetic friction. So that's why it's good to have your wheels turning and not sliding when you're driving your car. Because you have more friction, you grip the surface better when you have static friction. It's always harder to start something moving than it is to keep it moving. Picture you're moving some books across the room, you put them all in this big box that's too heavy to lift. You try to push it. It takes a lot of effort to start pushing it and getting it going. But once you get it moving, you don't have to push as hard to keep it going. So that's the difference between static friction and kinetic friction. Now let's talk about the coefficient of friction. The coefficient of friction describes how rough or smooth a surface is. It's a number, and this number describes the roughness. The bigger the number, the rougher the surface. It's denoted by the Greek letter mu. That symbol is the Greek letter mu. The mu s would be the coefficient of static friction, and mu k is the coefficient of kinetic friction. Now, mu has no units. It's just a number. It is always positive, and it is usually between 0 and 1. Now, notice that's usually between 0 and 1. It doesn't have to be between 0 and 1, but most of the time it is. If you have a really high friction surface, it could be more than 1, but it's probably not going to be a big number. It's just a small positive number with no units. It's just a ratio. Now, the equation to find friction. It doesn't matter if it's static friction or kinetic friction, it's the same equation. Force of friction equals mu Fn, so mu times the normal force. To find the force of static friction, you're going to use the static coefficient of friction. And to find the force of kinetic friction, you will use the coefficient of kinetic friction. That's the only difference in the equation. It's the same equation every time. You just swap out which mu you're using depending on which friction you're looking for.